Good afternoon. So my name is Keith Curran. I am the database administrator and your IT administrator in the Oracle Cloud for your database. I have a couple of roles, and what I intend to talk about this afternoon is the state and the shape of your database and its data. We're actually going to get on the database, use it, do a couple of queries on it, show you how to connect to it through a third-party application. But first, I'm going to start off with a little bit of an introduction into the history of the relationship with Oracle real quick. Go over the challenges of migrating Box data and Postgres data and all of your data into the database. And then we'll actually go in and play with the database. The first thing I want to say, though, is I've learned a lot just by speaking with you during dinner. And I really, really think that these types of meetings are very important, especially, for our understanding, for my understanding, in my role, for what I have to do on the back end. The back end and seeing a database is not something that's fairly common. You want to see typically like a user end product, a software application that's, you press this button and it uploads your software. So seeing a database is kind of unusual, but you guys are all data scientists, so seeing data, of course, is no unfamiliar situation. Well, first, my role. So what I do in the Oracle Cloud for all of you is when you need an asset, such as a GPU machine to do deep learning, like Paul described, and what John Shepard's team does at Montana State University, when they need assets to be spun up in the cloud, it's my responsibility to not only spin up those assets, but to make sure that they're trained on how to access them and that they're properly firewalled behind the network. That's about as simple as it is in a nutshell. I manage 3 servers in the cloud presently. One is an R Shiny server, which you guys worked on yesterday, which was for the trial software, the prototype. I manage Montana's GPU server, and then I manage the web server and the database server. I'm also responsible for the backend development for your database. So I speak with farmers like Jesse. I go to their places, I sit in their combines, and I learn about how they put data into their Ravens or their Trimbles. And knowing that helps me to build better processes in the backend. It helps me to understand the flow of that data and how those relationships in the database should be scaffolded. In terms of database administration, we don't have a lot of people on the database right now, so I want to invite any and all of you to reach out to David Bullock and to me if you would like to get into the Oracle Cloud and start using that. The more people that are using that cloud, we have a generous asset allocation from Oracle for research of $25,000, and that's scoped for the next year and a half. So if you'd like to get into the cloud and start using some of these assets and start using the database, I cordially invite you to reach out to us so that we can get you there. Okay, challenges for migrating ag data. As you all know, each and every one of us in this room has our own way of saving data, naming files. We have our own conventions for what we want to name those columns. And every one of you has the best way of doing that. My job is to take all your great ways of doing that and putting it into a sandbox where it can be represented uniformly, where everybody can share the same nomenclature and work with that data together in a sort of a data commons. Presently, we have Box, and that represents the historical legacy data of the DIFM group over the last many years. And then we have a Postgres database, which is Montana's, and you just met Paul Hedges. That's his database that they built in Montana, which is fantastic. And so taking the Box data and then the Postgres data, using a third-party tool called Alteryx, we obviously analyze that data, make sure that it's copacetic and it's not garbage. And then we move it into a staging database, which at this case is Microsoft SQL Server. So this is a screenshot from Alteryx, and I won't explain that. But the Box files, we have 19,817 actual files in Box of various constructs, shape, CSV, Excel, and they sum about 41 gigabytes. It's not very easy or portable for 41 gigabytes to move that when you have to move it through machines. One of the nice things about using Oracle in the cloud is we use what's called block volumes. And so once that data is ingested into the cloud, I can take that block volume and I can move it to the server you're working on within a few seconds. And you can be using that data within a few seconds. We don't have to worry about transfer rates or transfer speeds. It happens almost instantaneously in the cloud, which is one of the benefits I'll discuss shortly. Once the data from Box is migrated to SQL Server, and this hasn't happened just yet, we will take the data staged in SQL Server, and we're going to perform a number of things against it. We're going to make sure, number one, that the data integrity is good. And then once we've ascertained that, we'll start running some of the alpha software development against that database, performance tune it, and when it's finally ready for beta, we'll move it to Oracle, and that's where we'll actually do the beta testing in Oracle. Why a centralized database? There's lots of good reasons why. I tried to narrow them down to what I thought was the most important. The first being foreign key constraints. What is a foreign key constraint? Well, when you think about the relationships in a relational database, you have entities. When I say entities, I mean crop consultants and university research collaborators. And those entities are married to farms, and that's your collaboration. Now, farms have farm fields, right? And we all know that yield data, protein data, all that raw data is related to those fields, which is related to a farm, which is related to a collaborative relationship between entities and farms. When you have a foreign key constraint, you're defining those relationships in the database so that a person cannot arbitrarily go in and decide to delete a farm. Because what would happen if you can imagine that? Somebody goes in there and deletes Josh Jones' farm. Well, Josh Jones' farm has fields, and those fields have maybe yield data or protein data associated with them. The last thing you want in a database is to have orphans, orphan data that's not attached or properly related to other important pieces of data. So that's a very important thing. It maintains, to some extent, the data integrity by having those foreign key constraints. Consolidation of multiple data sources. We all know that this data is comprised of CSV files, Excel, Postgres data, shapefile data, strewn amongst many of you, and then consolidated into Box. What this does is it takes all of the data in its various forms, puts it in a database form, and allows for uniform software development in a format that is more productive and more efficient, so that you've got this consolidation of data in one place where everybody can come to and sort of drink from the well, which is a segue to a data commons for large collaborations. In my job, the most, I think, important aspect of my job is to fundamentally try to understand how I can improve collaboration between growers and scientists, and how I can do that through making the back end as intuitive as possible, so that when development happens on the front end, it's as intuitive for the farmers and end users, crop consultants, and scientists as it possibly could be. The final thing, REST-enabled database columns, that more or less falls in line with database development. It also allows for third-party open source development as well, because what REST-enabled APIs do for a database is when you have your database columns and you REST-enable them and you create these APIs, you're offering a layer of obscurity or abstract layer to your actual columns, and you're opening it to the public so that people can use those APIs and develop tools for your database, if that's a choice that you wish to have. It also allows you yourselves, and for our development teams, to develop those tools as well. And so it makes it a little bit easier for them. I'm going to show you, so what's in the database, what's not right now. We've heard a lot about what's under development. One of those things is trial design. The other one is what Paul described just now. In fact, I've been working with the Montana team for the last 2 weeks on developing their aggregate tables for their deep learning models. And that's not done, but we're working on that now. What's recently been finished is the trial design tables. And if you're not familiar with an ERD is, the ERD is an acronym for Entity Relationship Diagram. Now, this is a copy, this is actually the website, difm-cig.org. I invite you to go there and take a look. I try to publish information to the newsletter as often as I can. And I try to do this in support of our development teams. In this case, we've got, and so what we've got here is the website, difm-cig.org. And I put the ERD for trial design here for the trial design development team. so that they can take a look at that. And what needs to happen next is development will ensue against the database tables that I created, and we'll test them. And, a lot of this was a thought process working with Brittany, Taro, Paul, and a lot of other folks to determine the best design. And the only way we're going to know for sure is once we start doing actual development against it and, putting the rubber where the road is, so to speak. All right, so now I'm going to go back. Oracle partnership benefits. I cannot state enough how generous Oracle has been with their grant of assets and lenient they have been with the time that we've been in their cloud, sort of loitering about. The first thing that they offer us is cloud infrastructure. And cloud infrastructure are those assets that I described to you. They're the servers, the cloud networking, it's the software development tools that they provide to us. But more than that, it's the resources that they offer. And I'll give you an example of that. It's the third item down, so the development support, Code Innovate. I was recently at the Oracle Cloud World Conference in Las Vegas, and the folks that were talking with there at Oracle were very excited about this project. They want to help this project. And one of the things that they had offered, and I was pretty blown away with this, they offered us several weeks of actual Oracle developers to work with us to build some software tools with us. So in this case, I think I had proctored trial design to them and then building that within the database using Oracle Apex. So this is something that's in the queue, I think, for February, and it extends all the way to what Paul was describing. They want to work with us on the AI modeling too, and get our folks working in the cloud, doing the deep modeling in the Oracle Cloud as well, and developing actual software to accomplish these things. And that's free for us, which is really key because it's pretty expensive to hire a software developer. And so the goal, and I hope in the next few weeks we'll pan this out, is to get together with them, and then we'll hatch out a plan to build these tools, and Brittany will be a part of that. I know John's team in Montana will be a part of that, to build the software using the development teams that we have at DIFM presently. And so that's kind of exciting in terms of how they support research like ours. And the only thing that we have to do in order to get that for free is I have to go to Oracle and I have to say what we did and talk to their bosses and just say, yeah, we had a good time doing this and this is what we accomplished. So storage and data backup redundancy is important, right? We can't underestimate the importance of making sure that data is always available to us. Autonomous database and data warehouse. What is autonomous database and data warehouse? Well, Oracle's autonomous data and database, basically it patches itself, it builds its own indices, and it pretty much removes my role as a DBA because it manages indices, it looks at the performance of the database, and it builds those indices and fine tunes those indices to always ensure that you have the optimal performance on that database. And so it's kind of an exciting new technology that's only been around for a little while. And that is the ultimate goal where we want your data to reside. And of course, tools for rapid application development. What you're seeing here is a screenshot of the cloud, and you're looking at the Ubuntu server, which is the RShiny server for trial design. Montana's machine is there, and you've got the Yukon Windows server, which hosts the database and web hosting it. It's probably really blurry. Sorry about that. Okay, so this is the fun part. We're going to connect to the database right now. There are many ways to connect to the database. I'm sure all of you who are data scientists know what ODBC is, Open Database Connectivity. Third-party tools like RStudio, Python. This is an example of what the ODBC is on your Windows machine. You would simply just log in with your credentials, create an ODBC file in your system, and then you'd be able to access it with your third-party tools. And I'm not going to go out to the connection string for Python. I'm going to go to the third-party tool now. Alteryx. Oops. So I'm in a third-party tool now called Alteryx. It's an analytical tool. And so I just dragged and dropped an input data tool. And what I'll do is I'll configure that tool to connect to the database right now. I'll go to data sources. I'll see that Microsoft server is up here. I'm going to go to ODBC. Presumably, you've already set up your ODBC. You'll go to the appropriate server. You'll type in your user credentials. And when you click OK, It's going to bring up a window that will allow you to choose the table input that you want from the database. So the first thing you'll do is you'll choose the database in the server, and then you'll choose the table that you wish to work with. In this case, we're going to take a look at all of the farm fields for the OFPE program that presently reside in the database. And I'm going to choose just a handful of information here. And boundary. Boundary is a geospatially enabled binary field, and it allows this third-party software to project an image of your fields, kind of like what David's been displaying in several of his presentations, where all of the different OFP locations are. This does it in real time using data from your database. And we click on Run. And now if we want to take a look at what this looks like. So now you can see that those dots are actually, this is coming from your database. Those are physical representation, geospatial representations of your fields here in Illinois. These are the fields that exist for all your farms. And when you zoom in on these fields, they're not points, they're boundaries. As you can see, maybe. So there you are. That's a third-party tool that you can immediately start using to access the data in the database. And this is a simple demonstration of being able to, if you're an administrator, obviously, if you are from Montana, then you're not going to see Illinois' data unless you've got a grant of access, correct? If you're from Illinois, maybe you won't be able to see somebody else's data. Certainly, if you're a farmer, you'll be able to see your own fields. You won't be able to see all of these fields. I'm an administrator, so you're getting to see everything right now. All right. And so what I'm going to do now is I'm going to build a query in the database using SQL, which is going to be boring for some of you, and I apologize for that. But what I'm intending to display now is a relationship between entities, farms, farm fields, and then the products by year in those farm fields. I'm going to do a simple query and show basically what's in the database for those years, for those fields in those farms, for those entity collaborations. So if you're not familiar with SQL, there's an actual tool you can use to build this. And again, entities does not necessarily mean university entities. It could be Stanley, it could be Michael, who's not here now. It could be a crop consultant. Farm, and we're going to choose farm. Farm field. We're going to choose yield, and then products. And I'm doing it this way because I want you to kind of see the visual relationship here with these fields. And what you've got here is the very core, you've got entities, and a farm has an ID entity column which relates to the entity ID. And a field has a farm ID that relates to a farm and relates it to a farm. These are your foreign key constraints I mentioned to you earlier. Similarly for a field, for the yield data, it's associated with a specific field. And then you've got products, which goes to the products table. Now, why have a products table? Well, when you look at this raw data, everybody names wheat or a variety very differently. You'll see wheat underscore 16H, wheat 16H, 16H sometimes. And what having a products table does is it distinguishes the nomenclature to one product. You're not having all that variability in the product name. And that's why we have that products table. And there's a few other things you can do with that products table, like assign a price to it once it was purchased to do some cost analysis. So I'm going to choose entity name. I want to see farm name, field name. I'm going to sort and group by year. And then I'm going to display the product name for that year. Yeah.
My computer is an hammer, okay? So, all right, so this, to put this in terms of I understand, I'm gonna try to tell you back what I know. So your entity is similar to, you work with SMS, they have a farm, they have a grower, farm, and then field. Your entity would be the grower, right?
No,
Okay,
the entity is you.
so I'm the entity, but I've got 4 or 5 different farms. How do I link the grower in those farms? Like I work with colonies.
Mhm.
The colony stays forever, but the farm boss changes.
Okay,
My grower who's running the place changes.
sure. There's another table called CRM. It's like content something management. content relation management. And that person is attached to a farm. So you can move that person in and out, attach them to a farm. That's another table. And so if you're talking about individuals that are associated with a farm, you could associate individuals with a farm through that table. Okay. Yeah.
You know how screwed up this would be if I got in there for even 2 minutes.
Yeah.
You could send me a fireball.
No, I should have said something preemptively because you're going to see things in here like, so here's a really distinct difference between like an end user product and the back end. What you're going to see here is that when we do searches using database criteria, we're using ID fields and integers. So you're not going to know who farm ID number 20 is. You're not going to know what field 137 is, right? So the front end displays what that field is, but when you choose that field using common language, it saves the integer to the database. And why do we use integers? Well, when you're going to be, we're expecting to have over 1 billion records in some of these tables. And when you're searching through 1 billion records, it's inherently more performance tuned to search using integers than through strings, right? So that's kind of why we do that. And so don't feel overwhelmed. Now, I don't know how that's not displaying very well here. I apologize. Maybe if I'm going to see if I can make my display larger here. Yeah, that was a little better. Yeah. Okay. So what we're looking at here is this is a query of you're looking at all of the data in the yield table presently, and all this gibbly gobble that you've seen here is us sorting it and grouping it by your entity, then your farm, then your field, and then the year, because we want to see. So if you were, why would you use this query, first of all? Okay, you want to see, an administrator wants to see all of the farm data that might be missing for a particular year. And if you're looking at this, you're going to see that for Hanson West. Okay, well, I've got 2018, this Bailey farm, I've got 2019, I'm missing 2017. Hanson Pasture's got, why is that repeating? I don't know why that's repeating. Adams, 2018, 2019, 2020, you're missing 21, right? So maybe, and it tells you what the product is here. And it tells you how many yield points you have for that particular year, for that particular product, for that farm, field, and then you can associate those relationships. Now here you have the field ID, and I put that there as sort of so you can kind of see what I'm about to do next. Let's say you found a problem with the year 2020, Bonhoff Adams, corn, and you know that that's field ID 10. Well, you don't know that. You're just going to select that, but the database is going to go through and produce that. And we want to see the actual raw yield data for that specific farm. So normally in a user interface, right, this displays, and then you take your mouse and you click on you drill into the data by clicking on something like this, and then it produces this code in the background that's highlighted, and then it produces the raw data when I execute it. And now you're looking at the raw data for that field for 2020. Okay? ID field 10, you can see that it's 2020. And if I span across, this is kind of what it looks like. It's yield data. It's at your Latin long and it's at your GIS points. And we put some import notes in there as well. This is a University of Illinois field. We capture the data set information from their original raw data, and we put that in import notes. And I try to do that whenever possible. This will reside for a little while. Ideally, you don't want to have something like import notes on each individual record. So at maybe several years in the future, that will be removed to enhance performance of the database. Any questions so far? Is this really boring, everybody? I'm bored. Yes. Then you can link. There is a linking table that allows the producer to link as many collaborating entities as they wish. They can select that, correct? Yes. And you as an entity can do that as well, and should be able to do that. Oh, yes. Yes. Yep.
I got a question, and I'm gonna, if I get Mike rolling, okay? They're very, very concerned about their farm data on the cloud and it getting hacked. I know Oracle is a good database and a good, as good as that. But what do I tell my growers?
Well, I can tell you that I built Oracle's firewall is Oracle's firewall, but I'm the one that manages it. And I can tell you that there's hacking attempts every single day. I see it. That doesn't mean they get in. In fact, they don't get anywhere close. That's the nature of having a powerful Oracle system.
Say, Keith guaranteed.
And talk to the boss there. Yes. Yeah.
Free. But a lot of data forms on here have, as far as I know, never been hacked. Maybe they have, but I've got growers that absolutely refuse to put their data on the cloud because they're worried somewhere someone told them that they'll lose all their data and somebody will steal it and do stuff. Okay. I'm not trying to call it.
Not at all. It's a great question. There are some options that are available. For example, you could create a stipulation in the data for a particular farmer if that data was to be quarantined or to be only not to be displayed in any public forum. You could encrypt it. Oracle has very particular encrypting algorithms that you could individually assign to records that would belong to a farm. It gets a little bit more complex, but these are options that are available. And usually that kind of encryption is reserved for government sensitive data, health information, credit card information data, but it can be done.
Another question. Part of this database is for researchers to be able to use it. Is there going to be an opt-in, opt-out? Where the grower can go, yeah, and opt me in to let Bruce look at my data and use it. And I
Yes.
heard you earlier that you say it's going to be anonymized, it will be anonymous data so that they're not knowing who the farmer is.
That's something that can be done for sure. What you're describing is, at least in my esteem, a subscription-based model. Or if it's not, then I think what you're describing is if a farmer wants to assign Stanley, your big Sky Agriculture consulting firm, with Montana State University as part of his collaborating team, right? Then that's something certainly they can do. And we can account for that in the database presently.
Like I said, it's mostly Hutterite colonies. These people have an 8th grade education. They're not real computer savvy. They can pull things, and it's like, I've worked in databases, not to the extent you have, like I said, I break them, that's my job.
You're going to be my beta tester.
At one of my places, I was the guy they gave the database to and said, here. Then I turn around and give it back and they fix what I broke.
Yeah.
And that's what I did for 2 months. So, but they're worried about this. They're very concerned about their data and who has access to it, who doesn't. And I've heard it said here many times, we're going to have some open source. So if you've got a great idea, you can test it, trial it, which I think is awesome. I mean, it's going to leaps and bounds advances. But I think there needs to be a gateway where the grower can say, yeah, I don't put my data. I've got one grower, he doesn't care. And if you trust him, share my data.
I see where the bottleneck is. So when I said it was open source, that doesn't mean it's open source to have access to everybody's data. They would have to put their own data into the system, presumably through a subscription model that we devise, but they would have to have their own data, and then they would be able to use those APIs with their data only. They would not have access whatsoever to anyone else's data.
I misunderstand. Sorry.
No, that makes sense.
The way you want to find. And here's somebody somewhere has a really bright idea. Right? And you just want to remember, oh, this person, for who knows why, they just decided to contribute to the world by doing this new thing with us. Right? Well, the idea would be, this would be like that. Anything you want to, and then see the person who creates this data. That means after they get through some approval process, there's a new thing on the software that people can use. That's what they want.
I think it's awesome.
Yeah, Mike.
I'm just sorry, guys. I have a question. I'm just trying to pull this thing back around a little bit, but all right. Let's say we want to interact with NRCS, for example, on nutrient management across multiple states, across multiple territories like David, because they're across the whole nation, right? Same program, same features. And say we are trying to unpack the dilemma of nitrogen use efficiency. let's say Bruce is running trials for efficiency in Montana. I'm running them in, let's say, Washington, and there's people in Oregon and Illinois and Texas, all these things. Can we see each other's data? Or do we have to ask for access to it? So like if they're already doing it or it's already been done.
Yep.
There's no need in me wasting a year worth of research, or a year worth of effort within the group to try to capture that same unicorn, right?
Let's keep it real. That is exactly why you want a centralized database.
Yeah.
The protocols towards those ends, towards having access to that data, may involve a UA, a user agreement, or a data user agreement, right? Between the different individuals. You may already have those amongst yourselves where it allows you to collaborate with universities and partners. It would be presumed that that should be in place already. But in terms of the physical access, you would not have that, carte blanche. Obviously, if that was something that you needed, you would go to the project administrator or to the growers, and that access would have to be relinquished through an administrative decision, right?
Okay, so under that umbrella, right?
Sure.
That's perfect. I totally agree with that. But let's say we type in the search, like nitrogen use efficiency, will it show the projects of people that are actually working on it? So then you know how to contact or who to contact for permission for collaborating on the project.
Like that comment, and then maybe, hey, and maybe we need to have some place where we're going to publish what topics we are working on. And then say an interested farmer or crop consultant and say, hey, I would like to enroll some of my.
That's a fantastic feature.
Yeah, no,
It was basically, right, where you had online forum discussions. Imagine all sorts of levels, some for scientists. Oh, I didn't know that. That had that sort of conversation.
yeah, David, it happens a lot, right? You're doing research, you think it's your big idea, then you go to publish it, and all of a sudden you find there's. Right. So.
Yeah. That's a fantastic feature. And that, again, that goes to the heart of better collaboration.
Okay, that is possible within the system.
Absolutely. Absolutely. Yep. Any other questions? I don't have much more. I don't think any of you really want to get deep into the SQL side of things here. The purpose here today is to show you have a database. It's online. You can access it. For the development geeks in the room, I've done one thing to help facilitate better development practices, which is the actual physical database server that's in the cloud. They no longer have to use what's called IP addresses to access those boxes. I've created a DNS name. It's called mssql.difm-cig.org. And now they only have to type in that basically website and then of course their credentials to access the database server. And why have we done it that way? Because if we do change servers somewhat frequently, I'm consolidating servers now. And for them to have old IPs in their connection strings and in their development software, they would have a hard time keeping up and maintaining those if we made those changes. So in having them only connect to the website construct, I manage the IP differences in the DNS, and they're able to leave their connection strings alone. And that sort of helps out with development. And so I'm just going to conclude here.